Okay, I'll see if I can try this one more time. The alarm went off last time when I was doing this problem, so I'll reread the problem. Suppose $20,000 is put into account, paying 8% interest, annual interest compounded quarterly. That's 4 times a year. How much money would that take? Well, if I click on this part right here, I'm going to use that formula. And so let me write it down. A of t is equal to p times 1 plus r over n to the nt power. And filling the numbers in, then that'd be $20,000 times the 1 plus 0.08 over 4 times the 4t. And so that'll be $20,000 times 1.02 to the 4t. When you multiply that, that's 1.02. And I want A of 10 years. A of 10 years. So that'd be $20,000, 1.02 to the 4 times 10 power. Now I have that in the graphing calculator right here already typed in. 20,000, 0.08 divided by 4 times the 4 times t, and I got 44,160 and 79 cents. So that's 44,160 and 79 cents. And make that decimal place bigger and a comma there to make it handy. So that's how much we will have. So that's great. Let's see if I can get part B going. Question is when will we have $80,000 into that account? And so I'm just setting the value, the future time at $80,000. And I'm setting that equal to the 20 times 1.02 to the 4t. I want to solve for t. So that means I need to undo this multiplication. Dividing both sides by $20,000, I'll have 4 on the left-hand side and 1.02 to the 4t. Now, the reason why we had to get logs and everything going is so I could pull off this exponent. So if I take ln of 4, that'll be equal to 4 times t times natural log of 1.02. Natural log of 1.02 to the 4t. That exponent comes out in front, and I have that part right there. I want to divide both sides by 4 natural log of 1.02. 4 natural log of 1.02, and I should get my answer there. Wake up the calculator, and I want to throw in natural log of 4, ln of 4, divided by parentheses 4 times ln of 1.02, close the parentheses. So I typed in that, natural log of 4, and I had to make sure the denominator was all in one set of parentheses so it would do it correctly. And I've got 17.5 years. So 17.5 years is equal to t, and if I had a chance to check that, if I was done with the test, I'd plug 17.5 back into this equation and make sense. How often will it take to double? How long will it take to be double? Well, if I start off with $20,000 and it doubles, that'd be 40,000 is equal to 20,000, 1.02 to the n 4t. Again, I'm going to divide both sides by $20,000. And I'll have 2 is equal to 1.02 to the 4t. ln both sides. ln of 2 would equal 4t times ln of 1.02, ln of 2 divided by 4 ln of 1.02 is equal to t. It's really, really close to what I had before. All I have to do is change that ln of 4 to ln. All I have to do is change that ln of 4 to ln of 2. Enter. Move on over here and put a 2 right there. And I get 8.7 years. 8.75 years. 8 years and 3/4. And gosh, 8.75 years. And that's really close because at 10 years I had 44. In 9 years I should have it. I can check those examples. So again, to do the doubling time, I set twice the original amount. When I divide both sides by the original amount, I have a 2 on this side, and then what's left here after I divide by that is the 1.02 to the 4t. Natural log will pull that exponent down, and then I have natural log of 2 is equal to that, dividing both sides by the 4, and natural log of 1.02, which I did right there. I'm running it through the calculator. I get that answer right there. Since this has this already built in, I can check this one and type in 17.5 for the years. 17.5, close the parentheses, and I've got really, really close to the $80,000. I've got $79,901. And then I'll check my 8.75 and make sure that I have double that amount. 8.75 there, and I have nearly $4,000 within $2 of that. So that's a good time for the round off. So I think I've got all these answers correct. These seem to work correctly, and that I'm pretty sure is also correct. Well, thanks for watching this one, and I hope that's good.